Okay, so last week Friday, you guys learned about direct variation, right? And what that looks like. Did that make sense to everyone? We had 0, 0, and origin. We were really looking for the, does it go through the origin and is it a straight line? And if it met those two things, it was direct variation. It was easy to tell that from a graph, right? I think. Very easy. If you make a graph, you can tell. Does it go through the origin and is it straight? Okay, today we're going to talk about the equation, right? So does the equation would describe a proportional relationship. Again, it meets these two requirements, and this always has to be true. It has to pass through the origin and have a constant rate of change. Okay, that has to be true. So direct variation or directly proportional is a relationship such that as x increases, as y increases as a constant rate k. K is called the constant of variation. It's the slope or the rate of change. Okay, that's kind of confusing. Here's what I mean by that. It looks like this. I can get my screen to change. Okay, this right here is what we call the direct variation equation. Y equals kx. Okay, now the letter K is always a number. Okay, the letter K is always a number. This letter K represents the slope. It represents the constant of variation. It represents the rate of change. It represents the unit rate. It's all of those things. Do you remember how to find slope? Slope is what? Rise over run, right? You step up and over. Okay? So whatever that slope is, it goes right here. So when I look at an equation, like y equals 2x, I automatically know the slope. What's the slope in this equation? If whatever this letter k is the slope, what's the slope here? 2. Okay, if I ask you what's the unit rate is 2. So if I put this equation in context of a problem, maybe it's dollars per hour. You make $2 per hour doing whatever, babysitting, I don't know. Okay? The graph would look like this. It has a slope of 2. Is it direct variation? Yeah, it goes through the origin and is constant. The slope is 2, up 2 over 1, up 2 over 1. I can pick anywhere. Up 2 over 1, up 2 over 1. Okay? Questions on there? So when we look at an equation, we need to be able to tell if it shows direct variation or not. Okay? And a direct variation equation is always going to be in the form y equals kx. It has to be in that form. Y equals kx. It can't have anything else on it. It can't have a plus something or minus something. So when you look at letter A, is it in the right form? Is letter A in the right form? No, but we're going to verify it. So I'm going to automatically say that's not direct variation because it's not y equals a number times x. It has a minus. But let's do this. In this x column, let's put 0, 1, and 2. Okay, 0, 1, and 2. Okay, we want to know, does the graph pass through the point 0, 0? So if x is 0, and I put 0 in here, 3 times 0 minus 2. All I did was take 0 and put it in for x because I said x is 0. What's 3 times 0? 0. And then 0 minus 2 is negative 2. So y would be negative 2. Does it pass through 0, 0? No, it goes through 0, negative 2. So that answer is no. Okay, if x is 1, 3 times 1 minus 2. What's 3 times 1 minus 2? 3 times 1 is 3, minus 2 is 1. So we have the point 1, 1. If x is 2, 3 times 2 minus 2. That's 6. 6 minus 2 is 4. Does it show a constant rate of change? What do you think? This goes up by 1, up by 3, up by 1, up by 3. Does it show a constant rate of change? Is it going up by the same thing every time? Absolutely. But is it direct variation? No, because in order to be direct variation, both of these questions have to be yes. And if either one of them is no, it's not direct variation. Okay? So letter B, y equals 7x. I'm going to do those numbers again, 0, 1, and 2. Those are just really nice numbers to start with. Okay? So if x is 0, 7 times 0, what's y? 0. If x is 1, 7 times 1. What's 7 times 1? 7. 7 times 2. 14. Does it go through 0, 0? 0, 0 is there, so we would say yes. Is it constant? Goes up by 1, up by 7. Does that happen again? Up by 1, up by 7. So I would say yes, it's constant. So is it direct variation? Yes. Okay, it goes through 0, 0. It is constant, so yes, it's direct variation. Is it in the right form? Absolutely. Okay. Y equals kx. It's in the right form. Okay, look at the next one then. 4y equals x. Okay, let's try this. If I put 0, 1, and 2. Now, x is 0, right? So it's 4 times what equals 0? What would I fill in the blank with? 4 times what equals 0? 0. Right? 4 times 0 is 0. Okay, let's try the next one. 4 times what equals 1? That's a little trickier. Anybody know? Lexi? 4 divided by what would give me 1? 4, right? Dividing by 4 is the same as multiplying by what fraction? Do we know? One-fourth, right? 1/4 of 4 is 1. So y would be 1/4. 4 times what equals 2? How much of 4 is 2? Half of it, right? Half of 4 is 2. So we'd have to multiply by 1/2. Does it go through 0, 0? Is that point in the table? 0, 0? Yes. Is it constant? Okay, what it's going up by? It goes up by 1, up by 1/4. Up by 1, up by 1/4. Is it constant? Yes. So does it show direct variation? Yes, yes, and yes. Okay, if everything is yes, then it absolutely is. Okay, look at letter D. Again, we're going to make our table 0, 1, and 2. So if x is 0, we're saying 0 times what will equal 3? 0 times anything equals what? 0, all the time. So is there a number that I can put in there that's going to make it work? No, okay? This is really, right here, impossible. There is no number that I can put in this blank that will make it work. Okay, the other ones might work. Let's try. 1 times what would equal 3? 3. 2 times what would equal 3? 1.5. But look at these questions then. Does it pass through 0, 0? Absolutely not. Is it constant? No, because we don't even have a number here to look at if it's constant. So is it direct variation? No. Okay. Questions there? That making sense so far? Okay, flip the page. We are going to skip the next 2. Okay, so cross off those next 2 for sake of time. I think you guys kind of get the point when we did 4 of them. Okay, then let's look at this one. So writing direct variation equations. Okay, if I asked you to write the equation, it's not that hard. Okay, so this table shows the profits of a pie sale. It says write the direct variation equation to represent the situation. Okay. In this problem, what's the independent variable and what's the dependent variable? It's been a while since we've actually talked about this. Abby? In the table, the independent's always on the top, dependent is on the bottom. So in words, the dependent variable is the profit or the money. The independent variable is the pies sold. So if I look at this, it's money per pie. Right? The fraction bar just means the word per. So it's profit per pie. Okay, I could pick any one of these points. I'm going to pick this one because it's really easy numbers to work with. The money goes on the top, 60 over 10. What's the unit rate then? 6 over 1. What does that mean in terms of this problem? That means what, Abby? $6 per pie. Okay, this is the unit rate, also known as the slope, also known as the letter K, the constant of variation. So if I'm going to write the equation y equals something x, the number that goes here is whatever the slope or the unit rate is. So what's the equation? Lexi. Y equals 6x, because that's the slope. Okay, let's try one more. The height of the water as a pool is being filled is recorded in the table. Write a direct variation equation to represent the situation. What's the independent variable and what's the dependent variable? Here's the table. Which one is independent, which one is dependent? Remember, x is always independent, y is always dependent. Okay, always goes that way. X is independent, y is dependent. So it's height over time. Doesn't matter what point I pick. So I'm going to pick the first one this time. What number goes on the top? Which number goes on the bottom? So 2 over 6. I'm just going to simplify it. 2 over 6 simplifies to 1/3. There's my unit rate. My unit rate is 1/3. What does that mean in terms of this problem? What does the 1 stand for? Go ahead. the height of the water, right? So 1 inch every 3 minutes, okay? So this literally means 1 inch every 3 minutes. Okay, that's also the slope. 1/3, up 1 over 3, up 1 over 3. What's the equation then? Y equals 1/3 x. You just take the unit rate or the slope and put it in front of the x. So if we know that, predict how long it will take to fill a pool to 48 inches. If it takes 8 minutes to get to 24 inches, how long do you think it's going to take to get to 48 inches? 16. Because this is direct variation, we can just double this, right? Because it's going to keep going at a constant rate. Unless you run out of water or something, or the hose gets kinked, then it's not going constant anymore. But we're going to hope that the water stays on, we don't run out of water, there's no kinks in the hose, it's just going to keep filling at that same rate. Questions there? Okay, last one. The height of a television screen varies directly with its width x. Okay? So we have the height varying with the width. What's the dependent variable? Look at this. Which one's dependent? Which one's independent? Look at the graph. The dependent variable is the y. This is always dependent. This is always independent. So we have height over width. Okay, I don't want to use the 0.00 because that doesn't really help me. So I'm going to go here. I'm going to use this point. What's the height at that point? Abby? 100 over the width is 60. Can we simplify 100 over 60? Absolutely. We can divide by 10, which would be 10 over 6, divide by 2, 5 over 3. So the unit rate is 5 over 3, 5/3. So what's the equation? Abby. Y equals 5/3 x. Done. Okay. That means if I go up 5 over 3, every time I should be on the line. Up 5 over 3, up 5 over 3, up 5 over 3, up 5 over 3, and so on. Okay, it's hard to do it on here because it's so small, but can I go up 50 over 30? Same thing, up 50 would be here, over 30 is here, I'm on the line. Up 50 over 30, we're on the line. Okay? Questions there? We're going to skip that last problem. All right. So your homework tonight is a worksheet. Okay. Oh, wrong one. Sometimes it's easier to do a worksheet when we're doing some of that. Okay, so your job is to figure out, does the equation show direct variation? You're going to fill in the table. For every one of these, you guys, I want your tables to start like this. You're going to have x and y, 0, 1, 2. Okay, so on every table, when you have x and y, you're going to start with 0, 1, and 2 and try to fill in the other side. That will help you decide, does it go through 0, 0? Is it constant? Okay, use your notes. You guys can work together. Use your time. No, because if you double 8 is 16. You double 24 would be at 48. But it has taken 8 minutes to get to 24 inches. Does that make sense? No, it's already taken 8 minutes. You don't add another 8 minutes. It's gonna be a total of 8 minutes to get to 24 inches. If you're gonna keep going in another 8 minutes, it'd be at 48 minutes. 8 plus 8 is 16. So it's a total of 16.